Well, guys, today we will see what is Pascal's principle. Basically, Pascal's principle states that change in pressure applied on enclosed incompressible fluid is transmitted to every portion of the fluid and to the walls of its container. That means if you have enclosed fluid and externally if you increase the pressure, then that increase will be transmitted to every portion of the fluid, everywhere inside the container. Let us see how we can go about this. You have a container here and there is a liquid inside this. This is enclosed. Now, this container is enclosed by this piston. You can assume this as a piston. And due to this piston, just below the piston, if you have pressure as P external, then what will be the pressure at P, which is a point in the liquid below height H. Pressure at P will be basically P external plus rho G H. I think in this equation there should not be any doubt. Now, if we increase this pressure by delta P externally, we are increasing this pressure by delta P. So now, since your fluid is incompressible, so by increasing this delta P external, there will not be any change in the height H. So what will be the new pressure? New pressure at P, suppose there is an increase, assuming delta P, then this will be P external plus rho GH plus your delta P external, which you have increased. Correct? I think this equation also there is no problem. And this gives you delta P is equal to delta P external. Which proves the Pascal's principle that if you have a change in pressure inside an enclosed fluid, incompressible, provided the liquid is incompressible, then it is transmitted to every portion of the fluid because delta P is not dependent on H or any other point specifically. It is applicable for every point inside the container. So this proves. Now it has got a very good application that I would like you to explain. This is basically, this system is called hydraulic machinery. Now by this piston, suppose you are applying force of F1 and this portion is having the area is A1 Then what will be our pressure here? Correct? This is basically, this force is being applied externally. So increase in pressure will be like this. Now, as per Pascal's principle, this is transmitted to every point inside the container. So that means this must be equal to, this pressure must be equal to here also. And here, suppose you have this force is suppose this one downward, then naturally for balancing, this is upward, and this area is A2, then this must be equal to F2 upon A. So this is basically what is this is called output force, and this is called input force. So let us see what is output force. It is nothing but F2 is equal to F1 into A2 upon A1. This is the principle of hydraulic machinery. And let me give some numerical values here. Suppose your F1 is 10 Newton and A2 is 4 times A1. This area is bigger, is kept deliberately bigger just to see what happens. Into 4A1 upon, this is giving you 40. So here what is happening? You are applying a lesser force, but you are getting a greater force as an output force. So suppose heavy machinery is there, or car is there, or anything which is very heavy. If you want to lift, then you can apply the use of this hydraulic machine. You can apply a small force and you can lift the bigger heavy weight. Here again, one more thing is there. You are applying a force of F1. Suppose this is down by V1, this piston. Then what will be the volume displaced? It will be A1 into V1. This, whatever volume you are displacing here, that volume should go up here, and suppose lifting is your, here it is lifted by D2. And what will be, since volume is same, correct? So here D2 is equal to A1 B1 upon A2. So that means with the hydraulic machine, if you are applying a smaller force to a greater distance, whereas greater force is being applied for a smaller effect. You are getting a greater force with for a smaller distance. That means work done here will be same. Work done where will be F1 D1 must be equal to F2. Correct? So for having the same work done, input work done is same as output work done. With this hydraulic machine, you are going to lift larger or heavier machines. So you can use, so Pascal's principle is basically used for hydraulic machines.